Hi, and welcome to section 6.3. As you can see, there's only one video for this section. There's a lot of information. It's a little longer video, but I didn't really find a nice break point. So I figured it was easier just to do this as one video and kind of follow through because everything sort of ties one thing to the next. In section 6.3, we have trig functions of angles. So in section 6.2 we are talking about acute angles. In section 6.3 we're talking about any potential angle measurement. So the first thing we want to do is look at a triangle in standard position. Remember, standard position had its initial side on the positive x-axis. So let's call that x. We have a terminal side. So this side over here has value y. Whatever the height is that we're coming up on the xy plane, whether it's y over here, it's the same height over on this side. And then we're going to call the hypotenuse in this case r, like as in a radius of a circle. And the measurement we're looking at is this theta down here. Now obviously in this triangle this is another acute angle, but this terminal side could be anywhere around with the vertex at the origin, and it could be more than 90 degrees. So we're going to be looking at any possible value for theta in this case. So if instead of talking about opposite, adjacent, and hypotenuse, we're going to use our values of x, y, and r. So we have the following, and again this is probably a cheat sheet item that you want. Our sine of theta would have been opposite over hypotenuse. So in this case, it's y over r. Cosine of theta is x over r. Tangent of theta is y over x. So some of this probably seems familiar from in our chapter 5, y over x. Y over r, and so forth. So cosecant is related to sine, so that's just r over y. So in this case, y cannot be 0. Obviously, it makes that undefined. Secant of theta is r over x, and x cannot be 0. For tangent, in this case, x can't be 0. Cotangent of theta is x over y, and so y cannot be 0. Again, it would cause an undefined condition. So instead of talking about opposite, adjacent, hypotenuse, now we're talking about x, y, and r. So the first definition I'm going to give you guys is a reference angle. So for reference angle, we say let theta be an angle in standard position so the reference angle I'm going to erase these ratios here so that it doesn't run into the other and get you confused. So our reference angle, we're going to call it theta bar. So before we had like t bar, now we have as our reference terminal point. Now we have a reference angle, so that's theta bar. So the reference angle theta bar associated with theta is the acute angle formed by its terminal side and the x-axis. So what this means is, if we have our initial side is on the positive x-axis, and I have some angle here, theta. Obviously, that's not an acute angle anymore. It's bigger than 90 degrees. So our theta bar would be this guy here, the angle that's formed between that terminal side down to the x-axis. So that's what this definition is talking about. So let's look at a couple examples. Let's say we want to find cosine of 135 degrees. So if we draw our angle here, well, this would be 90 plus 45 puts us over here. So this would be our theta is 135 degrees. The reference angle would then be what? This would be 45 degrees left over. So cosine of 45 is equal to what? It's equal to square root of 2 over 2. But where did we end up? We ended up in quadrant 2. And in quadrant 2, is cosine positive or negative? Well, in quadrant 2, cosine is like our x value, so cosine is negative. So cosine of 135, because we're using this reference angle, is equal to square root of 2 over 2, but it's negative because in quadrant 2, cosine is a negative value. So we have cosine of 135 is negative square root of 2 over 2 using this idea of a reference angle. So we can do this for any angle, this idea of using the reference angle to figure out what would the measurement be, and we do the following. So evaluation of trig functions for any angle. So the first thing we're going to do is find the reference angle, like we did, like the 45 degrees. So find the reference angle, and that's our theta bar. We want to determine the sign of the trig function. So we did that. We knew we were in quadrant 2, and we were talking about cosine. So in quadrant 2, cosine is negative. So that was the next part that we did. And then third, the value is the same as the reference angle. Except possibly the sign. So maybe sometimes the sign is the same. If it's positive, it's positive. It just all depends what quadrant we're in. Except possibly the sign. So I'm going to erase this. We'll do a couple examples. So if you need to pause to finish writing, go ahead. So let's try these examples. We want to find the following. The first one is sine of 240 degrees. So the first thing we're going to need to do is find our reference angle. Well, we know that from the start over to this side here is 180 degrees. So if we want, we can do minus 180, which gives us 60. So then therefore, this terminal side would end up here, and this angle in between is 60 degrees. So that is our reference angle. So then our theta bar is equal to 60 degrees. So then 60 degrees is like what? It's like pi over 3. So sine of pi over 3, or sine of 60 degrees, is what? It's equal to square root of 3 over 2. Then, so that's part 1 is find our reference angle, and then part 2 is determine the sine. So in quadrant 3, the positive or negative value for sine is what? Well, it's negative. They're both. Cosine is negative, sine is negative. So sine of 240 is still going to be square root of 3 over 2, but because we're in quadrant 3, this gets a negative value. So therefore, sine of 240 is minus square root of 3 over 2. So we found the reference angle, found out what that value is at that point, which is square root of 3 over 2. Then we determine the sine of our terminal side, which is in quadrant 3. So sine in quadrant 3 is negative, so negative square root of 3 over 2. All right, what if we have the following example? We want to find sine of 16 pi over 3. So this is one like back in chapter 5, where 16 pi over 3, we're going around the circle quite a few times. In fact, if we want to change this guy, 16 pi over 3, if we divide 16 by 3, that gives us 5. So we get 5 pi. That's 15, so there's 1 left over. So this is really 5 pi plus pi over 3. So 5 pi puts us where? Well, it's 1, 2, 3, 4, 5. So 5 pi puts us over here, and then plus pi over 3 puts us down here, which happens to be the same as this 60 degrees, this pi over 3. So we have pi over 3, that's square root of 3 over 2. Because we end up in quadrant 3, sine in quadrant 3 is negative. So this also has a value of negative square root of 3 over 2. All right, so let's look at another type of example. So we have the following. If tangent of theta is equal to 2/3 and theta is in quadrant 3, we want to find cosine of theta. So if you remember, back in chapter 5, we had some problems like this, and I told you whenever we are specified which quadrant we are in a problem, that is of utmost importance. It means when we start sketching things, or when we have a terminal side or something like that, we have to take into account what quadrant we're in. So if tangent of theta is 2/3 and we're in quadrant 3, what that means is when I draw my triangle, It's going to be down here in quadrant 3. So if I call this angle here theta, so from this side down to this hypotenuse, that value is theta. And I'm drawing it so that the hypotenuse is in quadrant 3, where it tells me that it ends up. So if that's the case, tangent is what? Tangent is opposite over adjacent. So it'd be opposite over adjacent, but because we're in quadrant 3, that means what? This is actually a negative value because I'm coming 3 units to the left, and then I'm going down 2 units. So tangent of theta is really negative 2 over negative 3. The negatives cancel out and give me 2/3. So tangent is 2/3, but the sides of these triangles now have negative values because it's in order to put me into quadrant 3. So that is so important for these problems. So when we're given these kind of problems, you have to make sure to account for these signs on this triangle, or you're very likely going to get the problem wrong. So now, if that's the case, if this is my triangle, I still need to find out the length of this side, because cosine of theta would be what? Cosine is adjacent over hypotenuse. So cosine of theta is minus 3 over whatever this value of r is. Remember, we're talking about x and y and r. So I need to figure this out, and I can do that using Pythagorean theorem. So if I call this side r, then I have r squared is x squared, which is negative 3 squared, plus negative 2 squared. So I have r squared is negative 3 squared is 9, negative 2 squared is 4. So you can see the negative signs are gone. R is always going to be a positive value. X and y could be negative depending what quadrant we're in, but r is always going to be a positive value. So that means r squared is 13, 9 plus 4, so r is equal to the square root of 13. So if this is square root of 13, then my cosine is x, which is negative 3 over r, which is square root of 13. And if I want to rationalize it, this is the same as negative 3 square root of 13 over 13. So given that tangent is 2/3 in quadrant 3, cosine of theta is equal to negative 3 over square root of 13, or if we rationalize it, negative 3 over root 13, negative 3 root 13 over 13. All right, one last topic here. If you need to pause and catch up, feel free. So the last part of section 3 has to do with area of triangles. We have the following. The area of a triangle with sides A and B and included angle theta is given the following. So if I have some triangle, so if I have a triangle with side A and side B, and the included angle means the angle that connects side A and B. So if that included angle is theta, the formula is that A, the area, is equal to 1/2 A times B times sine of theta. I will tell you now, in this semester, we're going to have 2 types of problems for area of the triangle. This is the first one. You're given 2 sides and an included angle. The other kind is where you're given all 3 sides. Those are obviously very different problems, but people always get confused and start combining. You don't need to. The problem's going to be one of 2 types. 2 sides and an angle, which is what we have here, or another type that we'll learn down the road. So let's look at an example. So we want to find the area of triangle ABC. And we're given the following. So we have our triangle ABC. The side down here is 10 centimeters. This side is 3 centimeters. And the included angle is 120 degrees. So we're going to have that the area is equal to 1/2 the length of one side, which is 10, the length of the other side, which is 3, and then sine of 120. So 120, we can use our reference angle. So if we have our standard position, 120 is over here. So that means what? That means that our reference angle, so this would be 30 degrees in here, 90 plus 30. So the reference angle is 60 degrees. And because this is in quadrant 2, then sine in quadrant 2 is positive. So this is the same as sine of 60 degrees. So this area is 1/2 times 10 times 3, and sine of 60 degrees is square root of 3 over 2. So 2 can cancel with the 10, give us 5. And then we just multiply across. So 5 times 3 is 15 times square root of 3. And in the denominator, the only thing we have left is this 2. So the answer would be 15 square root of 3 over 2. And if we want to put the units in there because we had centimeters, it's centimeters squared. So that's using our formula, using our idea of reference angle, because it's 120 degrees, it's the same as sine of 60 degrees. Plug that value in, do any cancellation and computation, gives us our answer. So that's section 6.3. Again, that was the only video for that section. We'll see you guys in section 6.4.